So next topic is multicast communication or group communication in distributed system, and this topic you can refer from book that is Distributed System by Colleris. Okay, so multicasting or group communication is nothing but it's the process of sending a message from one process to group of the processes. So usually there will be a set of processes who will be forming a group, and if I want to send a message to all the members of that group, then I need to give the group IP address, and the multicast router will be forwarding my message or distributing my message to all the members of the group. So usually in computer network there are three types of communication. One is one to one communication, multicasting, and broadcasting. So one to one communication is also called as unicasting. So when a process is directly sending a message to one another process, so that is called unicasting. In case of multicasting, one process will be sending a message to a group of the other processes. So group should be formed beforehand before communicating the actual message, and all the members of the group will be getting the message. Now in case of broadcasting, if I am broadcasting a message, it means I am sending the message to all the members or all the processes that is there in the network. So here in this particular topic, we are going to see how the multicasting is performed in distributed system, and what are the various protocols to be used, and the reason why we need to go for multicasting in distributed system. So this we have discussed just now, that multicasting is nothing but sending a message to a group. That means sending a message to all the members who belongs to a particular group. So why we need multicasting in distributed system? There are many reasons. There are many applications of multicasting in distributed system, but here we will see four important application or four important characteristics of or the advantages of using multicasting in distributed system. The first one is fault tolerance based on replicated service. So replicated service means duplicate services. So in case of distributed system, as we had seen in the first chapter, that one of the major requirement is to be fault tolerant. That means even if some server fails, still the client should be getting the services. So server provides services. Now instead of having one server providing services to the client, if we have multiple server providing same services to the client, okay, those are called replicated server, because they will be providing same services to the client. Now in that case, how it is going to work is, so let us say we have this many servers which are replicated servers, same server, or they are doing the same task, that is to provide some particular, let us say, X service to the client. In that case, whenever a client sends the request, that request will be multicasted or sent to all the replicated servers. Now here, to send, the client will be generating only one request, but that one request will be duplicated by multicast router, and that will be forwarding that same client, one client request, which will be copied or duplicated, and that will be forwarded to all the replicated servers. Now all the replicated servers, after getting the request from the client, they will be processing the request and providing services to the client, and ultimately client will be getting one response which will be based on the voting. That is, maximum answer will be taken as the correct answer. Now what happens if we do this is, it will be more fault tolerant. That is, even if some of the server fails, the client will be still getting the services, which is one important requirement of distributed system. Next advantage of using distributed system is discovering services in spontaneous networking. For example, mobile network, which is a spontaneous network. Suppose let us say if I'm currently in one network, that means I'm connected to the server of this network. Now whatever messages, or if I have to do phone call, that will go through the server of this network, and if I'm getting any incoming call, that will also come to me via the server of that particular network. Now since it is a mobile network, we keep on moving from one place to another place. So if I move from one network to another network, immediately my mobile phone should be connected to the server of that particular network. So every network will have one dedicated server. Now when I'm moving from one network to another network, initially I will not know anything about the server, where the server is located, or which node is currently acting as the server. Now in that case, multicasting is used. That is, as and when I move from one network to another network, immediately the request message will be sent to all the servers in that network. So all the server will be forming a group, and the request will be sent to all the servers. Now whichever server is the server of that network will be sending reply back to me, and from there I'll get to know that I should be connected to this particular server. So this server is called discovery server. So whenever we have to find the discovery server in a new network spontaneously, okay, immediately, then multicasting is used. Next use is, or the advantage is, better performance through replicated data. So we had seen this one also in the first chapter, that in distributed system, a data will not be placed in one location. It will be placed in multiple location, again to make it fault tolerant and to provide the better services. Now whenever we store data in more than one location, what happens is that if a user performs any updation in the data, so if we want to change any data value, user will be doing that change in one of the location, but the same data has been replicated and placed in multiple locations. So if a user is making any change in the data of one location, the requirement is that change has to be reflected in all other location wherever the same copy of the data has been stored. So here also multicasting is used. So whenever a data is updated, that updation will be immediately reflected in all the replicated location wherever the data is kept, and this will be communicated via the multicasting mode. Next advantage or use is propagation of event notification. So what happens is that if we want to notify about some event, okay, if something has occurred, and if I want if the application is such that if that particular event occurs, then this many people needs to be intimated about. So in that case multicasting is used. So notification of any event that happens will be sent to all the members whoever are interested in that event via multicasting. So later on we are going to see a model, that is publish subscribe model, or the protocol in the distributed system that makes the use of multicasting mode. So in case of publish subscribe protocol, what happens is that the processes whoever is interested in a particular event will be registering for that event. Let us say in case of stock market, suppose if I want to know about some product, okay, or some stock, whether it is going up or down, then I'll be registering my interest. So if anything happens or any change happens in that event, then I'll get notification. So that notification will be received by many users whoever had shown interest to that event. Now this propagation of event to the interested parties is done by using the multicasting method. So now we are going to see how the multicasting is implemented in distributed system. So it is done by using IP multicast. So it is a protocol which will be installed on top of IP. So as we had seen that there are various layers for the communication, and in the network layer the mandatory protocol is IP, that is Internet Protocol. Now on top of Internet Protocol we can also have IP multicast protocol that is going to facilitate the services related to multicasting. So what are the services that is related to multicasting is, first of all, we need to form the group, that is we need to have the services of registering a process into the group. Then whenever the multicast communication happens, the multicast packet needs to be distributed to all the members of the group, and if any process wants to leave the group, there has to be a provision of removing that process from the group. So IP multicast is the protocol that is used for multicasting, and it is built on top of Internet Protocol. So we have seen previously that on top of IP there are so many other protocol that runs, that is ARP, RARP, ICMP, IGMP, TCP, UDP, and IP multicast is one of them. So using IP multicast we can send a single IP message to a group of members, wherein sender will not know about the ID of who all are going to receive the message. So sender will create only one packet and it will be sent, but in between in the network the duplicate copy of the same IP packet will be created and it will be delivered to all the members of the group. Now how the group, what will be the address of the group is, as we all know that in internet every node is uniquely identified by IP address. So to uniquely identify a node we need to know the IP address of that node. But along with the IP address, a node can also have another IP address that is called multicast address, that is to which group that node belongs to. Suppose if there is any message that is destined for the group, okay, suppose in a message group IP address is given, that means the message will be delivered to all the members of that group. So this multicast IP address is defined or specified by class D IP address. So we all know that IP address, in case of classful notation there are 5 different classes: A, B, C, D and E. Class D is for multicasting. Now its first 4 bit will be 1110 in IPv4. So what happens is that every node which wants to be connected in internet, they need to have IP address, but along with that if they want to be part of any group, then they need to get the group IP address, that is the multicast address from class D. Now with this one they can also be member of multiple group. So in that case one node can have multiple multicast address. So how it is going, how the entire process work is, first of all, to become the multicast group, the process will have to join the group and get the group IP address, and all the datagrams or the messages that is destined for the group that has the group address will be delivered to all the members of the group. Now usually in transport layer, so this was about the network layer. Now if we go up in transport layer, there are 3 protocol: TCP, UDP and SCTP, and mostly that is in the from the application programming point of view, if we are using IP multicast, it uses UDP in the transport layer. So if we compare TCP and UDP, we know that UDP's header size is much more smaller in comparison to TCP. So communication will be very fast, but UDP is not reliable. That is, if message could not be delivered to the destination due to some reason, there is no way of informing this to sender. So prominently in transport layer we know that there are two protocols, that is TCP and UDP. TCP is reliable but it is heavy, whereas UDP is non-reliable but it is very fast. So in comparison to TCP and UDP, which protocol in transport layer is used by IP multicast is? It is UDP. In IP label, it is the socket that has to belong to a group, then only it will be considered as a member of the group. Another important requirement for multicasting is to have the multicast router. So in network we need to have a router which should be capable of identifying group address and creating duplicate copy of same message and delivering the message to all the members of the group. So that is called multicast address. Now while multicasting also, we can use to limit the propagation of a datagram or the message. So for how long a multicast packet can be propagated, that can be limited by using the time to leave field. So what happens is that since multicasting means creation of lot of duplicate packets, so if we do not have any mechanism to destroy those duplicate packet, then after some time network will be congested with lot of packets. Okay, so that is why, since multicasting creates many duplicate packet, and how that will be destroyed, it will be destroyed based on the time to leave field of the packet. Now multicast address allocation, this we have seen that class D address is used, which ranges from 224.0.0.0 to 239.255.255.255. So there are different application area wherein this from the class D also different sections of the IP address has been provided. Multicast address may be permanent or temporary. So in class D also there are set of addresses, okay, which if you want to use, you need to buy from ISP, that is internet service provider. That is called permanent IP address. So if you have permanent group address, that means that address will also be always belong to you. Even if there is no member in the group, that IP address will be considered as a address of some particular XYZ group. Now if you want to use temporary IP address, then we can directly use it from in internet. We can get the pool of IP addresses which are temporary. So that means if there is temporary, means there has to be at least one member in that group, then only that IP address will be valid, otherwise it will not exist. So that is your temporary IP address. Now next we are going to see failure model of multicast datagram. So what is the failure model in multicasting? Now as we have seen previously that IP multicast use UDP in transport layer. Okay. So if it is using UDP in transport layer, it means whatever failure UDP suffers from, IP multicast also suffer from same failure. So why does it use UDP? Is because it is very fast, because in multicasting our main prime focus is not to deliver the message to each and every member in the group. Okay, our main focus will be to make sure that network do not get congested and the communication is very fast. So that is why UDP is used with IP multicast. Now whatever, as I said, whatever failure UDP suffers from, the IP multicast also suffer from same failure. So failure that UDP suffer from is, it is unreliable. That is, if packet gets dropped in the network, okay, or if some problem occurs, then there is no provision of informing this back to the sender. So this is called omission failure. So since UDP suffer from omission failure, IP multicast also suffer from omission failure. Now if you want to implement IP multicast using Java API, then we have a class called multicast socket, okay, which is a subclass of datagram socket. Now this multicast socket also has many functions, out of which join group and leave group are two important one. Join group means if I want to, if a process want to join a particular group, then it will have to use this function join group of multicast socket class. And if I want to leave the group, then I'll be executing this function, that is leave group, which is there in multicast socket class. So this was about the multicasting, how it is done in distributed system.